All right, this is the lesson for March 23rd during the corona outbreak. We're going to begin by talking about how we build polynomial functions and how mainly we're going to be talking about end behavior. Our warm-up starts with a little review of how quadratics looked. So we have two functions, and we just want to draw arrows for their end behavior and sketch the graph. So there's going to be a couple things that are similar and translate over to polynomials. One is that this linear factor, when the function's written in standard form, the linear factor is going to give us the y-intercept. And if we remember about parabolas, this a value is what we called it for parabolas. In polynomials, we're going to call it the leading coefficient. If it was negative, that parabola opened down. So it looks something like this. And same thing here, the linear factor tells us the y-intercept. And now the a value is positive, so our parabola opens up. So that's the language we used in parabolas, opening down or opening up. We're going to start using end behavior. So this would be, actually, we would call this one like down, down end behavior. This is up, up end behavior. So the difference about these functions is one opens up and the other opens down. All right, we're going to begin the notes. If you need to pause the video at any time to copy down what I've written, do so. Okay, so end behavior can be inspected in an equation by looking at the degree of the polynomial as well as the sign of the leading coefficient when the polynomial is in standard form, right? That's important. Okay, it needs to be in standard form, so you guys have to kind of get in the habit of putting these polynomials in standard form. So if the leading coefficient is positive and the degree of the polynomial is odd, then you have end behavior that is, as x approaches negative infinity, it's down, and when it's positive infinity or to the right, it's up. If the degree is even, it's up, up, from the right and left. If the leading coefficient is negative, we basically have the opposite of this. So it's going to be, instead of down, up, it's going to be up, down. If the degree is odd, and it's going to be down, down, if the degree is even. And remember, this is both when the leading coefficient is negative. If the degree of the leading coefficient is even, the far left will be up, and the far right will be up. So it'll be up, up. And that's with a positive leading coefficient. If you have a negative leading coefficient with a even degree, negative, then it's going to be down, down. If the degree of the leading coefficient is odd, you're going to have down, up for positive, and up, down for negative. And again, pause the video if you need to copy these notes down. Now we're going to look at some examples. So example 1, we look at our leading coefficient. It's 4, which is positive, and the degree is odd. So what is that going to tell us? It's going to tell us on the left it's down, end behavior, on the right it's up. Next one, leading coefficient's negative, the degree is even. So negative leading coefficient with even degree, that's going to tell us that it's down, down, left and right, end behavior. Now we're going to start practicing these end behavior notation. I like to start by drawing arrows just like I did in example 1. So this is going to have an odd degree with a negative leading coefficient. So it's going to be up, down. So as x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches negative infinity, right? When x is approaching negative infinity, it's way out here on the left. So this is left, this is right. It's always going to be like that. Okay, so we have positive leading coefficient, even degree, and positive leading coefficient. This is going to be up, up in both directions, left and right. So both will be approaching positive infinity, f of x. And remember, f of x is just our outputs, our y's. So that's why these are approaching positive infinity on the left and the right. Now we can draw our own unique polynomial function with the given end behaviors. So this is going to be some even degree polynomial with a positive coefficient. So 3x squared minus x would work. This is going to be up on the right, or I'm sorry, the left, and it's going to be down on the right. So this is going to have a negative coefficient, leading coefficient with an odd degree. So an example could be negative 2x to the third power. And you can add anything as long as it has a lower degree than 3 here. So like plus x squared minus x plus 2. And these other examples are going to have to wait because I need to instruct you guys how to use Desmos because we don't have access to graphing calculators. All right, stay well, wash your hands, and we will get through this. All right. Mr. Swercheski out.